My professorship is about design methods in food. The things that I work on is working on increased use of design methods in agri and food areas. We develop simple tools for students and teachers and businesses. And we try to increase market success of meaningful innovations in food and agri. And I don't know if you know the HAS, but it's a University of Applied Science in the field of all kinds of agricultural studies, but also has studies on food technology, but also food innovation. And that's the last part is where I am sitting in. And my background is I'm a food technologist from Wageningen University a long time ago. And so I know a little bit about proteins, about rheology. I worked with Campina for 12 years and since last 13 years at HAS. And I'm also a part-time artist, so I make 3D mosaics. So I was always very interested in the 3D footprinting from a personal point of view. But in my line of work, of course, we're interested in new innovations, and students are always interested in new technologies. And in food innovation, we have three types of students. There are students who are looking at new designs, food designs, new packaging, and new marketing and business opportunities. So it's very interesting to look at 3D footprinting as a radical innovation. And this is a very simplified way of thinking about it. But if you have a certain vision, like Nina Hoff told us about, we have a vision about how we see the future, then you can backcast that future and try to make small steps of innovations that consumers can understand and recognize. And it's my experience that these small steps are really, really important for consumers so that they understand and recognize what it is they're looking at or what it is they're buying. So for me, 3D footprinting is quite a radical innovation because we're still at the starting point. There are not so many systems yet. There are not so many products or applications yet. Limited suppliers, almost no producers, but it was nice to hear about Barry Calabout, what they are doing. And also, therefore, not so many target groups yet. So we're all still starting in this field. But it's nice to see that in the 3 or 4 years that I'm working on 3D footprinting, that there are really steps being made. What I do see is that students working on 3D footprinting need to understand. It takes a long time really to understand not only the possibilities, but then you need the technology, so the formulation of recipes. You need to know about how the piece of equipment working. But also, if you want to make intricate designs, you need to know about that as well. So it's quite difficult for students to really work on this. So I always bring them into, I always give them a workshop before they start. Otherwise, they don't come very far. We work a lot. This is one of the students that worked on a project on 3D footprinted ice cream. In this case, she tried to find out what is possible from a marketing and business point of view, how we can develop ice cream 3D footprinted for children with cancer. We worked together in a previous project with the Prinses Maxima Centrum in Utrecht, which is a special hospital for children. And they have a lot of children that have cancer. And we thought about the idea of using 3D footprinting as a way to give some interest in children's lives. When they're having cancer, they're a lot in hospital. And another problem with children with cancer or people with cancer is that when they're having chemotherapy, they have a lot of change in tastes. Their mouth is raw and they need smooth taste. And as Lilia also said in our previous slide, malnourishment is quite a problem with these children, because not only are they in hospital and they don't like hospitalized food, but they need special foods which are high in calorie, fat, and to feed them. So we try to put this one-in-one together with a nice shape. So this is a project of one of the students about this, and I hope that in the future we can go further with this. This is another project that was done for a company called Floating Farm. It's in Rotterdam, and you see on the right-hand corner the farm at the moment is for cows, and it's in the city, in the harbor. And the same company wants to build a chicken farm next to it. And they were wondering about using 3D food printing as a concept for visitors when they're visiting the chicken farm. So they asked students to make a product made with egg. And they decided that they would use an egg salad, which is based on egg and cream cheese. And they gave it some tastes, and they developed also a little toast, which can be used as a printing. Below, on the right-hand side below, you can see a small a biscuit, which they developed, and you can keep it quite crunchy, and then print on top a certain shape, a very simple shape, but nice enough as a snack when they are visiting the floating chicken farm. So this is also some idea of what students can do in a few months' time. A larger project that we've been working on for quite some time is about enjoying food when you are having dysphagia. Dysphagia is a name for people who have chewing and swallowing problems. We are already working on this project for a few years, and these are the first students focused on using food waste as ingredients for making products, but now we've moved on, and I can tell you a little bit about that as well. This is a project we started last year, and we wanted to do a test with people in caring home, and as you can see here on the left-hand side, this is typically a plate from people who have dysphagia, and on the right-hand side is a plate that we serve them in an intervention week, and we wanted to have a few various amounts of people with dysphagia. Unfortunately, we were left with one patient who had dysphagia, and the rest were either already better. So some people have dysphagia for a short time, or they didn't want to work with us, or they were mentally too ill to work with us. So in the end, this test was done with one person. And what we did was we weighed the plate before and after, also in the baseline measurements. We observed the reaction, and we asked about eating experience from this person. And what we found out is that from this one person, we already found quite a lot. We saw that per day it differed what she ate. So the amount that she ate was different per day. And when we asked her about it later, she said, "Well, I like meat very much." So she was very very interested in meat. And what we didn't see any improved eating from the 3D food printed plates, but she said she was very pleased with the added experience of attention. So we also found out that even though the students didn't give her the food, so people from the healthcare home gave the food, but because they were sitting in the area to look at what she was doing, she experienced quite some nice extra attention, and so this made her very pleased. So that's one of the problems you have when you're doing a setup, that you sometimes have, you influence more than you think. So this was a very good pilot for us. We then wanted to have a new test, so we started with a group of different care homes in the area, and we wanted now to test with 20 clients at least, with people with temporary dysphagia, with non-congenital brain disease. So it's it's due to accidents, and people with Parkinson's disease. And the study will be a crossover intervention. That means that we will divide the groups in two, and both groups will have 5 days of baseline and 5 days of intervention meals, the lunch meal, and we will be weighing the plate again and asking survey questions afterwards, also to clients, but also to the nurses who are feeding them. And we started last February, we had a problem, of course, that we had COVID in Holland, and we were not allowed to go into the healthcare homes because of all the problems that they were having this year. So the first half year, the students focused on their on making the recipes and the products. So I can show you those. So what they will be doing, here you see various products that will be printed beforehand and frozen, so that they will be put frozen on the plates, and with a meal butler it can be regenerated immediately before dinner. So in this way we already have taken the half-year time to develop all the recipes and all the forms, so that can be used one-on-one in the test, starting hopefully February next year. So just to give you, that was what we are doing now and what we will be doing next year. So hopefully next year I can give you some results about. Of course, I'm always thinking about what are the next steps with 3D food printing, and I really would like it when one of my students or more of my students will start their own business in 3D food printing. I also think there is a very much interest in high protein snacks that are tasty. So I agree with you, Lilia, that there's much need for high protein snacks. That could be with plant proteins, but also insect proteins are quite interesting to look at. And I also have this dream that in the future there will be not only food factories with 3D printing lines for chocolate, but also for recycling food, because I think a lot of the food waste that we are making can be used to make 3D printed foods with. I thank you for your attention, and I hope that there are some questions for me.